Hi, I'm Ben April, Chief Architect at DomainTools.
And I am Paul Vixie. I was the founder of Farsight Security, which has since merged with DomainTools.
Welcome to this episode of Reflect and Amplify. Today we're going to welcome Chris Mikkelson. Chris is a distinguished distributed systems engineer at DomainTools, formerly at Farsight. Today we're going to talk about message loss in real-time systems. We had an interesting model at Farsight where we built into our systems the idea that some constructive loss is okay. And that turns out to be an interesting topic when we get into big data systems and real-time environments.
I would say it's not just okay, but during the times that it's okay, it's actually desirable. And you can call him Chris if you want, but he'll always be CMIC to me. For the audience, I want to say we'd like this web series to be as relevant as possible, which means to you, which means we need to hear from you. We've set up an email alias, reflectamplify@farsightsecurity.com, with which you can tell us what you would like to hear about, or more likely, what you would like to stop hearing about. So that address again, reflectamplify@farsightsecurity.com. Keep those cards and letters coming.
You're also encouraged to throw questions into the YouTube chat. Our lovely producer will forward those on. And I should also say this is a great time to remind you that we need your help feeding the YouTube algorithm. So likes, subscribes, whatever else works there.
If you feel we've earned it.
Yep. All right. So without further ado, welcome, Chris.
Good afternoon, gentlemen. Thank you for inviting me.
Well, thank you for joining us. So we often got a lot of raised eyebrows around the campfire at Farsight when we would talk about we're okay with loss. What would you say constructive loss means to you, Chris?
Well, I mean, like first of all, I'll just say that I kind of come from a like data management world where like the words data loss are what you use if you want to like strike fear into somebody. You get a lot more get a lot more capacity, but of course lead times for capacity are a little longer than you can say, oh, we're just managing the data loss. So constructive loss is really all about you're recognizing that although in an ideal world, there would be no loss, and as an application developer, things that you're working with might look like there's zero loss. There's loss behind the scenes that's being managed by whatever system you're interacting with, and converting the loss into things that the system thinks are less objectionable to you, like stalls, drops, like unbounded delays. And it's that in a lot of contexts that those are quite a bit worse than just a loss, especially when you're talking about like a massive stream of data that's going to have a lot of repetition. And if you lose it, you're going to get it next time. I've worked in systems where you're collecting like periodic reports from network elements, and if your data goes away completely, it'll be back in an hour. And like that sort of recovery time unattended is actually pretty good. Compared to the experience of having your operations team scrambling for 2 hours to try to get it to recover in less than an hour.
Two hours of ops time to fix a 1 hour gap is that's a losing proposition.
If you're measuring it in hours, you're clearly not doing security work. But what I'm remembering here is that TCP/IP transforms loss into delay. In other words, the underlying system of TCP is meant to say, hey, I didn't get it the right thing in the right order and so forth. I'm going to wait for it to be retransmitted or somehow. And so you will eventually get everything that was transmitted, but eventually could mean seconds or minutes, depending on what's going on down there. And it turns out with security, that is turning loss into delay just means it was bad, so you made it worse. And I'm remembering in the old days when I used to care about running networks, SNMP, being a UDP protocol, was wonderful at this, right? If there's congestion or loss, a downlink or whatever, then yeah, you'd miss a data point, but that's okay because by the time you got the next data point, you would just sort of know how long it was between data points. And so all of your graphs would still look pretty, but you would not waste any of the network's time trying to tell you that it was down while it was down. And this is not intuitive. Was it intuitive for you, Chris, when you first came on board at Farsight?
Um, it was intuitive, but I had to unlearn a few things. Because like obviously I want to make sure that as much data as possible comes through, and my previous high volume UDP experience was all running DNS resolvers, and there the loss very pointedly goes into delay, and delay that faces somebody who is going to be calling somebody who's 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 going to be paging you, and which is obviously a pretty big downside versus we'll get the next sighting of this.
So the difference there being between interrupting a user's ability to operate and the observation that we're capturing somewhere. So.
Yeah, or more generally that a request response definitely benefits from reliability and rapid retry and that kind of stuff because of the latency sensitivity versus a processing pipeline that you want to get a reasonable end-to-end time, but the individual latency isn't as clearly felt.
All right. So how do you tell the difference between constructive loss and, say, entropic loss?
Let me jump in there. An example of non-constructive loss might be illuminative. In the domain name system, you often have more than one server you could be asking some question of. And some clients will kind of try them all and spread the load. Others will say, hey, that one worked. I'll keep using that until it fails. But the problem you can get with non-constructive loss is if that first one goes down, everybody immediately gangs up on the next one down the line and kills it. So if it wasn't having trouble before, it is now. So you have to make sure you know what's going to happen when loss occurs in terms of how will the system react to it. Although that's not the main topic of what Farsight and now DomainTools means by constructive loss. It is important to remember that the system, it's a system. This is a distributed system, and it has characteristics. It behaves in certain ways, and in this case, it reacts in certain ways.
Yeah, but essentially, like if you're in a context where loss is going to be retried or moved somewhere else or similar, every loss is effectively a doubling of that data, which then of course tends to gang up on loss, which is kind of the subject of a lot of TCP's engineering over the decades, to figure out the best way to work in the face of occasional losses, like how fast to retry, like when to dial back to complete slow start, and things of that like. And also in talking about constructive loss, you kind of have to realize that this is not really this is not something that's been talked about a lot in like data processing or application level type situations, but in the design of network routers, it's a very well known idea because there's been work on like random early drop, Codel, and similar to just affirmatively take data that you already have in queue at the router and say, we're not keeping up. We need to pick something to eject from the queue so we can keep up with what's remaining in the queue, and try to. And then there's a lot of engineering that goes into making sure that method fairly impacts all flows going through the router, and does not interact poorly with common TCP or other applications.
Well, that's probably another illuminative example because you mentioned random early drop. The default back before anybody understood anything, and you got to remember, most ideas turn out to be bad because eventually we learn other things. And so the default was, okay, I'm a router. I've got a slow interface pointing to the world, a fast interface pointing to my whatever my campus. And if I get too many packets on the fast side to be able to send them all out the slow side, the default is we just drop anything that won't fit because we can only remember so much. And that's called tail drop. And as CMake just intimated, that was catastrophically bad for TCP, which is most of what was in those packets was segments of TCP. And so somebody came along and said, what TCP is designed to cope with is stochastic or just random drop. Bad things will happen, but they don't always happen in a certain order. And so if we could just randomly punch out certain packets that are in the queue, then we could probably get TCP to cope very well with the kind of loss that goes on with the fast to slow congestion. And that again would be a way to take the system's reactivity into account when designing what you yourself are going to do. Now, Jim Geddes and Dave Todd have been working on something called Buffer Bloat, and there's a website for it, bufferbloat.net. And so you mentioned Codal, that is an outcome of that project. And it turns out a lot of gateway operators, like the DSL modems in our houses, thought, well, gee, memory's cheap, let's put more in. And so instead of having 5 packets worth of stuff that was received on the fast side, can't yet send it out the slow side, you might have 5 million. And it turns out that, again, TCP behaves really abysmally under those conditions, and you have to constructively lose the packets that won't fit because the whole system matters, not just your part of it.
So a lot of environments that we see really expect every bit to be sacred, right?
Yeah.
We're going to build things to 5 or 6 nines of reliability and storage. What's the story we tell? How do we bridge that gap from we're all right with a little bit of loss as long as we get to decide where it happens, for folks who expect every bit to make it to the other side?
I think it falls back on the fact that, like so many things in life and everything in engineering, it's all about trade-offs. It's like, yes, we can get possibly 99% of the, or 99.999% of the bits through from one end to the other, but at what cost? I mean, are we going to have a network that is engineered to work towards its peak, or is it or are we going to work with something that can work towards 90% of its peak, and then live with the loss that comes with that? And similar with the computing capacity. Like, do we want to be having the administrative overhead of running a large cluster of machines when one machine will keep up with it at 99.9% of the time? Is it worth the extra complexity, cost, and obviously the new failure modes of a properly distributed system, or a properly sharded system, or however you want to put it, in order to capture that last 0.001% of traffic?
So when Robert Edmonds was putting together the DNS tap capability, which is network telemetry for DNS servers, he tried to get ideas from everybody in the company, including CMake, including me, including Ben. And my contribution, if we're going to call it that, was this specific area. Given this application, given what is the workflow that this technology is part of, what would loss have to be like in order to be constructive, right? You have to know the purpose in order to be able to say whether something is constructive or not toward that purpose. And, it didn't take long to realize that, if there isn't enough bandwidth upstream of a name server, right? So it's trying to answer requests. That's its primary duty in life. It should never fail to answer requests because it's too busy remembering those, recording or telemetrizing those requests. But within that constraint, let's say you can answer all the requests, but there just isn't enough bandwidth to send the telemetry about the requests you're answering. What should be lost? If it's not all going to make it, then you have to make a choice. What's going to get lost? And that's where constructive loss came in. And what we decided, and what is incorporated into the DNS tap design, is that the oldest information is the least useful. And so you have to have your own sort of user mode queuing. You can't let the kernel take care of this, because once you give something to the kernel, it tries real hard to get it all delivered, and it will translate congestion into delay. And that's not what you want. So we ended up with a design that put some things in user mode that is not usually in user mode. But in particular, that meant that there was a queue in user mode. And if the queue overflowed, then at the time you wanted to add one more thing to the queue, you would say, hey, it's already at quota. I'm not going to just to keep adding more and more stuff in memory. I have to drop something. And what gets dropped is the oldest queued information. In other words, the next thing that will be transmitted is what is lost to make room for the new stuff. And that's just because, in security, yesterday's newspaper is not as valuable as today's newspaper if you can't get them both. And so that was how we decided for DNS tap, which is, of course, one possible link in a very long chain that ultimately comes into Farsight DomainTools to be part of the security information exchange and used to build a lot of security-oriented technologies. Is there anything, CMIC, any other part of the system that is not designed that way? And if not, why not?
There are parts of the system that are designed in such a way that they do block and fill up a queue and just discard incoming data, and we keep an eye on those operationally to ensure that level of discarding doesn't descend into like a complete stall that causes that basically leads to seconds long failures or something of the system, or worse. And a lot of the reason we've kept those sorts of things is in order to manage the software complexity. It's one of the trade-offs that you have to keep in mind when you're designing these systems is, especially if you have like a large number of interacting systems. Any one of those systems that is complicated to understand is going to keep you up at night. And is going to be the shiny object that distracts everybody who's trying to troubleshoot the actual problem in the system elsewhere. So you wind up focusing on say a queue management strategy at one place versus a suboptimal choice of algorithm somewhere else in the processing pipeline.
Well, I can remember talking to customers of security information channels where they would say, but what is this thing in the stream that we're getting from you that is a loss marker? Oh, well, that means you're not keeping up. Oh, well, I don't want to not keep up. Well, then buy a fatter pipe. Well, can't you just put it in a file and send us the file? Well, I guess we could, but then, let's imagine that we close that file every hour. Well, that means half the data in it is older than half an hour and kind of useless. So if you want files, and eventually, as everybody here knows, we just said, all right, we give up, we'll make files. I'm tired of arguing about this, but you really don't want files. You really want a stream and you really want loss markers, because yesterday's newspaper is not as valuable as today's if you can't have both. But boy, we have that conversation with every single customer of the telemetry streams. I think in a way that might be why the database was always a bigger sale, or bigger sell, easier sell, was that people understood, I'm going to ask a question, I'm going to get an answer, nothing gets lost. I don't have to think hard about what to do if something gets lost. I like not thinking hard, then that's good. But ultimately, you'd really like to see what's happening now so that you can decide what to do while there's still time to do it, as opposed to get a reliable indication of something that happened a while ago. By the time you see it, it's too late to do anything about it. And that's, to me, this is all about how do we make the whole internet reactive toward the people who want to abuse it for various reasons. Um, is there any change? Have the customers changed their complainage about the streaming format and about the loss markers?
Yeah, we've gone to the next step. We've gone to a concern that the most recent file is too old. The minutely file has been closed for, or the minute has elapsed and the minutely file isn't available yet. So we've come full circle.
Yeah, and this is one of those things where it definitely takes both paradigms. Like you want to get the freshest data, but sometimes that data needs some context that's in the previous 10 seconds or so, and you need to be like buffering that in memory, or you need to be buffering that memory and keeping it up, or you need to just be able to ingest a file of it later.
I feel in a way that Farsight, where I was for 8.5 years with you guys, was simply the latest in a lifetime of opportunities for me to try to tell people that they've got to pull their head out of their own self-deception and make the hard choices instead of pretending they don't exist and kicking the can down the road.
We've seen a lot of cans.
Yep.
So, Chris, we do a number of things as part of the waterfall to go from raw observed data down to enriched weapons grade data. The raw DNS observations all the way to newly observed host names, something like that. How much do you consider some of those steps along the way as part of constructive loss? For example, deduplication or filtering. Does that enter your mind as part of the same pantheon?
Well, I think the constructive loss frame to me applies mostly to to same type of data in, same type of data out. The deduplication and the parsing of the raw data, the deduplication of the raw data is all like a refinement step or changing the model of the data, and so as long as that's keeping up. If that's keeping up, we're keeping up with the data flow, I guess. If I just said a little tautology there, sorry. So like I don't see that reduction in data volume as part of a loss. Because there are very few use cases for the data that we are throwing away. That is that we saw. We're already keeping the fact that we saw, say, something from multiple different name servers in a certain time period. We don't necessarily need to know which name servers they were, and if we did, we wouldn't want to really tell people which name servers they were, because that's between us and the name server operators. So let's see.
In an overrun of voluminous self-similar data, the law of large numbers seems to apply, which is that the things that you can't afford to carry, right? You're coming from the fast side to the slow side. You got to make a decision about what to do with what won't fit. The stuff that you're dropping, statistically speaking, is the stuff that is most likely to reappear shortly.
Right.
Yep.
Yeah, at the lower levels of enrichment, you're more likely to see it again some other point. Okay.
Do we have any comments from the YouTube audience? Any questions?
Nope, according to this. So
We got 5 minutes to go.
let's see. So, Chris, how much loss is too much?
Probably about 5% less than we're actually experiencing. It is like so many things a judgment call. It's like if as Paul pointed out, the self-similarity of the data is kind of a huge buffer against reacting negatively to loss in a data stream, because we probably will see what we lost again. In general, as long as we can keep up with we generally will consider it a bad thing if too many novel features are being lost. So we keep an eye on like the novelty of the output. So like if we start seeing like an anomalously low number of newly observed domains, we will say that's and we'll start looking to see if that's because of loss or because there's just not any newly observed domains.
Well, there's a principle that I think I've heard possibly by CMake, which is that essentially loss cannot be constructive if you are not measuring it, right? So these loss markers that are in our streams that inform us, obviously there's no room for telling you exactly what you lost, but at least how many you lost, it's got to be there. Otherwise, no matter what the loss is, it's not constructive.
Yeah, like the actual like numeric how much is too much is really more dependent on the effects outside the system. And in the case of like a data processing pipeline where you're already doing some sort of a sampling, even like spatial sampling, because you've only instrumented this part of the network, you're not in a context where you expect to see everything. So as long as you're still seeing things that are useful, and your processing pipeline is still going along, you could argue that this is an acceptable level of loss. It might mean that like if you're losing 50%, not saying that I've ever seen that. If you're losing 50%, that means that half of your data is wasted, and you should consider doubling your capacity. But if you're losing, losing 5% on the regular 1 or 2%, it's
if you haven't seen 50%, that just means you weren't here in the early years.
Yes, I was not there in the early year. Yeah.
You used a word just now that I think is fascinating as far as explaining how to think about constructive loss. Use the word sampling, right? Mm-hmm. So that's how NetFlow has always worked. It's never been possible to have take a copy of every packet that a router is carrying and give it also to the management system. So it's always been, you just kind of take one every so often and make sure, and you hope that it builds up to something that's representative. And I'm wondering, is that actually a principle we've been following all along, which is that to be constructive, the result after loss has to be representative, the way sampling would be?
Yeah, it's a kind of a very specific example of instead of solving the problem that would get you lots of research funding in academia, solve a related problem that is much simpler.
With half hardware.
If you structure your data so that almost any subset of it is useful, the largest subset you can capture is going to be good enough.
Ben, I think we're almost out of time here.
I think we're pretty close. Yeah. Thank you, Chris.
Thank you.
Chris, it's very good to see you again.
Good to see you too.
And if the pandemic continues to wane, I will let you know when my motorcycle and I are in the middle of the country.
Excellent. Look forward to it.
All right. It's time to get back to work. Thank you for joining us today. We'd love to hear your ideas for future episodes or follow-up questions for this one. Again, that's reflectamplify@farsightsecurity.com.
So let me just take you out by saying, we talk about reasonable expectations. We sometimes talk about wanting to make expectations that you have more reasonable than they currently are. In other words, move the needle on human history. So let me just hope that for our audience, may your expectations be or become reasonable.